Hey everyone, welcome into Unit 12, Day 1 Notes, and welcome and congratulations. This is the final unit of the semester and of the year. And let's get started. This unit is on systems of equations systems of equations, and today we're going to focus on systems of equations by graphing. So students will be able to solve systems of equations, of linear equations, by solving for slope-intercept form, graphing, and identifying the point of intersection with an 80% accuracy or higher. So, what is a system of linear equations? It is when we have two or more linear equations using the same variables. So, an example we have here, we could have 3x plus y equals 10. That's one linear equation. And then we could have 2y equals negative 4x plus 5. There is a second linear equation, and they are both using the same variables, x and y. So that's a system of linear equations. Now we're going to move into talking about solutions and then eventually how to solve these systems of equations. So this should be a recap here. A solution is an ordered pair, x or y, in coordinate form with our parentheses that make all equations in the system true. So if we look at that system and we plug in x and we plug in y, it should be true for both equations. Otherwise, it's not a solution to the system. But let's just recap real quick on how a solution works and what that means to make both equations true. So let's just look at the example where it makes one equation true. So determine if 3, 4 is a solution to each of the following linear equations. So 3 is our x value and 4 is our y value. We're going to plug those in. So instead of y, we're going to put 4, 2, and then 2 next to x means we're going to multiply by 3 because we said our x value is 3 minus 2. So that's where our numbers get entered. And now we simplify as much as we can. On the right side, we can do 2 times 3 is 6. And then 6 minus 2 is 4. Now, because both sides of the equation have 4, this is true. 4 does equal 4. So that coordinate 3, 4 is a solution to that linear equation. Let's look and see if it's a solution to this one on the right, y equals negative 2x plus 4. So same thing, instead of y, we're going to put 4. Instead of x, we're going to put 3 times 2. And let's go ahead. So we have 4 on the left. Negative 2 times 3 is negative 6. Negative 6 plus 2 is negative 4. So that is not true. If you were thinking 4 and 4 is the same, but 4 and negative 4 are not the same. So therefore, it is not a solution. So again, a solution to a system of equations is when an ordered pair makes both equations true. This ordered pair represents the point where both equations intersect. So when eventually, in a little bit here, we're going to be graphing these systems of equations, and we're going to be looking for when the lines cross. That is what the solution is, because both equations will be the same at that coordinate. So when we're looking for this ordered pair, that's what a solution represents, is where the lines cross in the system of equations. So let's take a look. Determine if the following ordered pairs provide solutions to the given systems of equations. Again, this is our x value, this is our y value. Now we have two equations, and now when we plug this in, it must be true for both of them. So we'll deal with this equation first. Y is negative 2. 4 times 1 minus 6. And now let's do our algebra, or do our math. 4 times 1 is 4. 4 minus 6 is negative 2. So it is true for this first equation. Let's see if it's true for this second equation. Negative 2 is in for y. We have 1 in for x plus 2. This is not true. So therefore, 1, negative 2, is it a solution? No, it's not a solution for this system. Let's go ahead and try number 2. We have 2 for x this time and 1 for y. So let's plug in 1 for y minus 2 times 2 equals -3. 1 minus 4 is -3. 1 minus 4, -3. So it's true for this equation. Let's check for this one. We'll plug in for y, 1 plus 1. And when we do 1 plus 1, we get 2. So yes, 2, 1 is a solution for that system of equations. Okay, let's go on to the next page where we are going to start talking about graphing to find the solution. So when solving a system of linear equations by graphing, you must solve each equation for y. That's the first step because we want to be able to graph it. And being able to graph it, we know we've practiced this first semester, is getting it to slope-intercept form, which is y equals mx plus b, where the m represents the slope and the b represents the y-intercept. Remember, the y-intercept always has a coordinate of 0, and whatever that value is for b goes second. Step 2, identify m and b. So we just talked about where that would be located, and hopefully we are pretty confident in doing that at this point. After we identify the slope and the y-intercept, we want to graph both lines on the same plane or the same graph. And then we want to write the solution as an ordered pair and check our answer. And we're going to do all of these things. So we're going to try 1, 2, and I think we'll stick with 1. Maybe we'll do 1, 2, and 3. All right, so for number 1, this is already in slope-intercept form. Y is by itself, and we are going to take this top equation and pick out its information on the left side. So the slope is -2, and the y-intercept is this +2, so 0, 2. Let's graph that one first. We go over 0, up 2, and then the slope of -2 means we go down 2, right 1, down 2, right 1, down 2, right 1. For this first line, you might want to graph a few more points because you're not going to be exactly sure where the second line is going to cross it. So the more you have initially, the better off you're going to be once you graph that second line. So there's our first line. All right, let's take a look at the second equation. We're going to put the information on the right. So there is nothing in front of the x, which means it's an invisible 1. So our slope is 1, and our y-intercept is 0, -1. So we take a look at our y-intercept. We go over 0, down 1. And our slope of +1 means we go up 1, over 1. So that's where our first point is. And notice that right away, that's our solution. That's where the lines cross. So I'm just going to finish drawing that in. And then I'm going to write the solution on our graph. So that coordinate where the two lines cross right there is 1, 0. So I'm going to put that over here. 1, 0, and now we're going to check our answer. The way we check is doing exactly what we did on the previous page. We're going to plug in our information for both equations. So for that first equation, it's y equals, which is 0 equals -2 times our value of x, which is 1. And then we're going to add 2. Now let's solve. So that's -2 plus 2, which is 0. So it worked out for the first one. Okay, let's go ahead and take a look at the second equation, where it goes y equals or 0 equals, and then we just have x, which is 1 minus 1, and as you can see, it works out for this one too. So we're just double checking to make sure we did everything right with our graph, because if this doesn't check out, that means we graphed it incorrectly, but it checks out, so we know our solution is 1, 0. All right, let's take a look at number 2. We have y equals -3. Now, if you remember way back when we were graphing linear equations, that when y is by itself, or y equals, and there's no value for x on the right side, then that means that our slope is going to be 0, because this is going to be a horizontal line. And our y-intercept will just be 0, -3. So we're going to go 0 down to 3. And then a horizontal line means it goes straight across, where our y value is always -3. All right, easy enough. Now we take a look. When it's x equals, if you remember, this will be a vertical line, which our slope is undefined. And we have an x-intercept, which will be 4, 0, not 0, 4, 4, 0. So we go over to the right and up 0, over to the right 4, up 0. There's our coordinate. We're going to go ahead, graph it, and see that they intersect at that coordinate right there, at that point, which is going to be 4, comma, -3. And if we go ahead and check this out, first one is y equals -3, so it's -3 equals -3. Okay, that checks out. And the next one is x equals 4, or 4 equals 4. So that one checks out. So we know we graphed that one correctly. Okay, let's go ahead and actually, yeah, let's do 3. We'll do 3 together. So this one we have y equals 2x. So whatever number is next to or connected to the x, that coefficient of x is our slope. So it's 2, and there is nothing being added on. So that means our y-intercept is just 0, 0. So we go over 0, up 0, right there at the origin. Slope of positive 2 goes up 2 to the right 1, up 2, right 1. Like I said, just strategically, we're going to do a few extra for our first line, just so that when we graph the second line, we can easily see where the intersection is going to be. And then always use a straight edge. There's our first line. Second equation, we have a slope of 3 and a y-intercept 0, -4. So we go over 0, down 4. And our slope of positive 3 means we go up 1, 2, 3 to the right 1. And we keep this going. 1, 2, 3, right 1. 1, 2, 3. So they intersect when you get to the very top there. So good thing we did extra points for this one. It gets kind of tight and close up there. So really make sure you're using your straight edge. Otherwise you might get mixed up here. Our solution for this is 4, comma, 8. And now we're going to check. So we go up to the first equation. It's 8, or it's y equals 2x, or 8 equals 2 times 4. Well, oops, that one checks out. The next one is y equals 3x minus 4, or 8 equals 3, x is 4, and then minus 4. This gives us 12 minus 4, which equals 8. So that checks out. All right, we will come back to 4 and have you work on that one by yourself, but we're going to do a couple more examples. We're going to go to the next page and do example number 5 and example number 8, and then we'll have you try the remaining 3 on your own. So 5 is a little bit different because we have to first solve for y before graphing. Now this we have done in the past, but it is new in terms of our notes today. So let's go ahead and start with this one. We have -2x minus 5y equals -15. So in order to get y by itself, we're going to add 2x to both sides. We're left with negative 5y on the left and 2x minus 15 on the right, because we cannot add these together. They're not like terms, and we want it in y equals mx plus b form, so the 2x is going to go ahead of the negative 15 or the minus 15. Then we divide by negative 5 to fully isolate our y value, or y variable, and we get negative 2/5 x plus 3. So our slope is negative 2/5, and our y-intercept is 0, 3. Let's graph this one. Over 0, up 3. Then our slope is negative 2/5, so we go down 2 to the right 5. We can even do it again, down 2 to the right 5. And we'll go back to our y-intercept and then go up 2, left 5. Up 2, left 5. And then take our straight edge. And there we go. There's our first graph line. Let's go ahead and now graph the second one. Just like the first, we have to get y by itself, so we're going to subtract 2x first, which leaves us with negative y equals negative 2x plus 9. Then we divide everything by negative 1. Negative 2 divided by negative 1 gives us a positive 2x, and then a negative 9. So for this one, our slope is going to be 2, and our y-intercept is going to be 0, negative 9. Let's go ahead and graph. Over 0, down to 9. Now we go up 2 to the right 1. And we're going to keep that going until we officially see that intersection happen. Once we see that intersection happen, then you can go ahead and stop and graph. And there we have it. So our solution is where the two lines intersect, which is the coordinate 5, 1. And now we're going to check that. Make sure we solved everything correctly and then graphed it correctly. So 5, 1, we have negative 2x minus 5y. So negative 2 times 5 minus 5 times y, which is 1, equals negative 15. So that's going to be negative 10 minus 5. Negative 10 minus 5 is negative 15. So that one checks out. Let's go ahead and try the second one now. We have 2x minus y. So it's going to be 2 times our x value, which is 5, minus y, which is 1, equals 9. That's going to be 10 minus 1, which is 9. And that checks out as well. So we know we did it correctly. We got 5, 1. Okay, last one we're going to do together, and you're going to try the last 3 on your own. Let's go ahead and solve for y. So 2x minus 5y equals negative 25. We're going to subtract 2x on both sides. Divide everything by negative 5. We get y equals negative 2 over negative 5 gives us positive 2/5 x. And then negative 25 divided by negative 5 is going to be a positive 5. So our slope 2/5, and our y-intercept is 0, 5. So let's graph that. Over 0, up 5. Our slope is positive 2/5, so we're going to go up 2 to the right 5. up 2 to the right 5, and then we're going to go down 2, left 5, down 2, left 5. Take your straight edge. Oh, let me redo that one. There we go. It's difficult graphing these lines with a ruler on a Chromebook screen, but we're doing okay. All right, let's go to the second equation and solve. So negative 4x plus 5y equals 35. So this time we're going to add 4x to both sides. 5y equals 4x plus 35. Divide, divide, divide everything by 5. And we get y equals 4/5 x plus 7. So our slope, 4/5. Our y-intercept is 0, 7. So we go over 0 up to 7. 4/5, we go up 4. Well, we can't go up 4. Otherwise, we're going to head off the graph. So we're restricted to only going down 4 and then left 5. 1, 2, 3, 4 to the left 5. There's where the two intersect. You only need 2 points to graph a straight line. So once we get that, especially if it's the one that intersects, just go ahead and connect. And then there's our solution. It is negative 5, 3. And let's check our answer. We have 2x minus 5y. So 2 times our x value minus 5 times our y value equals negative 25. So that's going to be negative 10 minus 15. Negative 10 minus 15 is negative 25. So that checks out. All right, let's check the second equation. Negative 4 times our x value, which is negative 5, plus 5 times our y value, which is 3, equals 35. So that's going to give us 20 plus 15, which is 35. So that checks out. Okay, so go back, try the final 3 problems, and we'll come back and see how you did. See you in a few minutes. All right, everyone, welcome back. If we take a look at number 4, these two equations are already solved for y and in slope-intercept form, so we can go ahead and identify the slope and y-intercepts in graph. When you do this, you will see that the lines intersect at 2, 0. And when you see that I have checked my answer, and it confirms that 2, 0 works for both equations in the system. Therefore, it's the solution. All right, let's go on to number 6. So this one we had to solve for our two equations to set into slope-intercept form. With the first one, you can see right here that it's y equals 2/3 x plus 1. So check that first. If you did not get y equals 2/3 x plus 1, then that's your first mistake. You know that that's where your error was. If it is so far, good to go. We get our slope 2/3 and our y-intercept 0, 1. The second equation, we get a slope of 5/3 and a y-intercept of 0, 4. When we graph these, we see that they intersect at -3, -1. And through my checking process, it looks like that it works out, but I actually didn't finish checking this. So let's do that. -15 plus 3 equals -12. So that checks out. -12 is -12. All right, last one to check, number 7. There was some solving to do. There was minimal solving to do because y, there was no coefficient with it. So we had nothing to divide by. But as you see, we go ahead and solve, get to slope-intercept form. The Solution appears to be 0, -1, and then through the checking process, it confirms that our solution is 0, -1. Awesome job today. First set of notes of the last unit of the year. Congratulations, guys. You're almost there. Just keep it up, and I'll see you in the next set of notes. Have a great rest of your day. Peace out.